got here is an old office shredder. Now you might remember that I've been banging on about speed and torque when it comes to generation in previous videos, and we did a load of videos where we showed what that relationship is. Now power output of a generator is proportional to the square of the voltage, so the quicker you can get that coil going over the magnets, the more you're going to generate. And as I say, we showed that in a number of freewheel and hand crank generators. Now the key to it is the gearing. And what we've got here is a gearbox. Let me give you a close-up. There's the motor, there's an induction motor, we've got the power boards, here are our cutting rollers, and there is a really solid gearbox. Now, this motor turns at high speed. Now, it's high speed, low torque induction motor, and yet it's still able to cut paper, which requires low speed and high torque. So this gearing system here translates that high speed, low torque into low speed, high torque, so it can become a paper cutter. We're really interested in that because if we can do it the opposite way around, we can put something in here at high torque, low speed, we should be able to turn a generator here in exactly the reverse. So let's get this out. And there's the whole assembly. It comes out as one part. It is a super chunky bit of kit. So obviously what we want to do is get this bit to pieces so we can have a look at the gears and really just inspect these just because they're so cute. And there's the gear train, and if we spin that, if I can, there we go, turns the motor quickly, and these are turning slowly, so obviously the reverse. Now we're going to pull those gears apart and finish taking this to pieces. Okay, there it is in bits. Now, this induction motor isn't easy to make a generator out of. If it was a DC motor, we'd just retain the whole thing, but because it's an induction motor, the more we need out of it is this bit, which is the gear that meshes, and of course, it has the rest of it that we can use as an output shaft. We're going to have to drift that off, which means just whack it with a hammer until it pops off. And then we'll get an output shaft. Of course, we need bearings, but we'll use this part of the motor for the bearing for that, because that's where it came from. So it goes nicely in there and gives us a bearing and an output shaft. And we need an input shaft that we're going to turn. And we have two choices, if you remember. We had this. They meshed like that, and then when you turned it, they sliced up the paper. We only need one of them because it's a 1-to-1 ratio, so there's no advantage in turning both of them, so we're going to turn one of them. We're going to turn this one because it fits neatly onto the gear actually there. So we need that bit as well, the gear, the gearbox, the motor shaft, part of the motor drive, and that bit there. Now that bit there is held in place by this sleeve bushing right here, so we need to cut that off there, and we're going to need to put a handle on that. We're going to need to take that off, and then basically all we do after we've done that is reassemble the gearbox. Anyway, let's do some cutting and hammering. Oh, quick tip when I'm removing bearings like this, I just put 2 bits of very stiff metal into the vise, put that in there and hit it, and then the bearing will come out. Otherwise it's a bit of a nightmare, to be honest. So that's the bit I'm going to turn. Now obviously if you're doing this and you're pulling apart a different paper shredder, it's going to be slightly different, but it needs a handle on it. On that I've got a bit of pipe, so what I'm going to do is take a 10mm dome nut, whack it in there, put a bit of a weld around it, and that should do it. So that's the gears just slotted back together. Now we can put the cover plate on. We've made the modifications. Needs a handle. Okay, so I've made a handle out of a bit of bent steel and a bit of pedal. Welded that nut on, a bolt onto it, and the bolt fits nicely in there. We give that a couple of winds to get the bolt on. There we go. Okay, and now when we turn that handle, there we go, and we get a huge spee out of the output shaft. So that is a gearbox for a generator now. If we put anything on there in terms of motor, it's going to turn quickly, which is exactly what we're looking for, and it's a really sturdy gearbox and really quite compact. Very similar to the bike stuff we've made, but really compact. So if you see a paper shredder, Don't just walk by it, have a think about that gearbox, grab it off, because you can make that gearbox really, really easily just by 2 simple adaptations. We stick a generator on the output shaft, something on the input shaft, and we should get good generation. Back to my gearbox. Anyway, this little motor here. Now, I don't know if you remember these motors. These motors are the £5 hand blender that I bought from the local big box store. I've got a light on it just so we can see what kind of thing it's doing, and then we'll take some measurements. Yeah, that's bright. Okay, let's link it up now and get some volts and some amps out of it and see what it's actually doing. Okay, I've got it attached to this, which is soldering on a resistive load, and we've got it on the volt reading. So if I give that a turn, we're getting 120 volts out of that. So no wonder that light was so bright. Okay, let's get it rigged up for an amp reading. And we're getting about 80 milliamps out of that. There we go, an awesome find. I mean, we were kind of unlucky in that we got an induction motor on this. A lot of these paper shredders just use a straightforward DC motor, so all you really have to do is stick a handle on it and you're gonna have yourself a generator. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to subscribe.